So what about for convex? How will it look like? So if this is it, this is how it will appear. This is the pole of my mirror. Like this. If you remember very well, we said a convex is presented like this. Just put a small curve like that. But which means the focal point is virtual, is imaginary. So which means it will be this side of the mirror because this is where the curve is. So which means we shall have our principal focus there. Then our center of curvature this side. It will not be this side, members. It will not be this side, but the reflecting side, the reflecting surface is this side. So if you have a ray of light parallel to the principal axis like this, we know that convex mirrors, what do they do? Members, what do they do? Do they converge or diverge? They what? They diverge. So you find that it will appear like this. It will come like this. It will be reflected from this point. Then it will be appear to be from there. It will appear to be coming from where? From the principal focus. So incident reflected. That's how it should be. Okay? Members, are we together on that?
Yes.
Yes. That is the first rule. For every ray which is parallel and close to the principal axis, it must pass through the principal focus. After what? After what? After reflection. After reflection. Take note of that. Members, take note of that. Number two, rule number two, a ray of light through the center of curvature, through the center of what? Through the center of curvature, is reflected back along the same, is reflected back along the same path. It's reflected back along the same what? The same path. Members?
Yes, teacher.
What is the second one saying? A ray of what? A ray of light through the center of what? Curvature is reflected back along the same what?
Path.
The same path. Is reflected back along the same path. Let me show you. I think from here I put it to be number 3. From here I put it to be number 3. In our notes is number 3. I think that number 3, a ray through the center of curvature C is reflected back along the same path. Okay? It's reflected back along the same what? The same path. So can we draw that ray diagram? Can we draw that? So we shall have this. Who is that one? So we are saying a ray of light through the principal focus, through the center of curvature, which means it will be like this. Like that. So it will be reflected, incident and reflected along the same path. Along the same what? Along the same path. Like that. Have you seen that, members? So every ray that is passing through the center of curvature, it will be reflected back along the same path. It will be reflected back along the same path. Let's also draw. Let's draw for convex. Let's also draw for convex. So it will be like this. I told you from here for convex, from this side is imaginary. Is imaginary. Imaginary. Then when you come here is now a real one. Because you can see it. So it will still be reflected back along the same what? Along the same path. Like that. That's how we draw it. That's how we draw it. Have you put it down, members? Have you put it down?
Not yet.
Okay.
But teacher,
Yes?
if the ray is reflected through the center of curvature, is there any image going to be formed behind the mirror, or it's not going to be there?
We shall see how the image, this one we are just looking at the key concept. We shall see, because what we need to form the image, we need at least 2 or more rays. 2 or more what? Rays for the image to be formed. But here we are looking at only single rays. We're looking at only a single what? Ray. So the image will not be formed with a single ray. For the image to be formed, we need 2 or more rays. Okay? Are we together?
Teacher,
Yes?
I'm somehow confused.
Yes, please. Where?
I thought the concave mirror
Mm.
and the convex, that's the mirror. What is that straight line?
The straight line here.
Yes.
This straight line, because there are sometimes, because we just use as this line is presenting the mirror. It's presenting, all this one is the mirror, okay?
A convex mirror.
Yes, we are just putting it to present the mirror because we can't draw a big curve, okay? We can't draw a very big one. So what we do, we just present it with a line. We just present it with a line, okay?
Okay.
So which means all of this is the concave mirror. But to show which type of mirror we are talking about, we just put a small curve here at the center of the mirror, okay? So when you see this one is presenting a convex. When you see this is presenting what? But all this one, all the line here, this straight line are presenting, all this is the reflecting surface. Is the reflecting what?
Yes.
Is the reflecting surface of that mirror, okay? Is it okay now?
Yes.
All right. Rule number 3. Rule number 3. Rule number 3. We are saying a ray of light, passing through the principal focus, or the focal point, is reflected parallel to the principal axis. Is reflected parallel to the principal what? Axis. Okay? Are you together? It's reflected parallel to the principal axis, and this rule only works or holds for concave mirror. Only for what? Concave what? Only for concave mirror. Are you together?
Yes.
So let's look at that. So if this is my mirror, This is my principal axis. I just put a small curve there to show which type of mirror it is, like that. This is my F, then this is my C. I told you the distance here must be approximately equal. We shall see how we are going to draw it when we come to construction of ray diagram now. So we are saying that a ray of light passing through the principal focus, focus like this. What will happen to it after reflection, members? It will reach here. What will happen to it after reflection? We said it will be reflected what? Parallel to the principal axis, which means it will be reflected like this. It will be reflected back like this, like that. So this one is incident, then this is what? Reflected. Okay? Members, have you seen that?
Yes.
Yes. So this is the pole of the mirror. So this one, the third rule is only work for a concave what? A concave mirror. Why only concave? Because for concave, its focal length and the principal, its focal length and the center and radius of curvature, they are real. They are what? They are real. Because when you look for concave, when you look for convex, the principal focus is virtual. Is virtual. Because why? It is behind the reflecting surface. It's behind the reflecting surface, which means that's why this rule, the third one, does not apply for convex. It is only applicable for a concave mirror. Are we together? That one is there are only 3. So let's look at, members, let's look at now how these images are formed. Let's look at how these images are formed. Subheading, characteristic of image form. Characteristic or nature of images formed by a concave mirror with the object placed at different positions. At different what? Positions. So that's our heading. Characteristic or nature of images formed by a concave mirror when object is placed at different positions. Let's start with the first one we are seeing on our screen. I think the first one we are seeing on our screen.
Yes, teacher.
Yes. That one is when the object is where? When the object is placed where? Beyond the center of?
Curvature.
Center of curvature. A object, let's just say object beyond center of curvature. Object beyond center of curvature. C. We start by drawing. We draw. Balance the book. This is what I have. Draw the principal axis. Members, are we together?
Yes.
So the mirror is a concave. So I just draw a small curve there. Then I shade the other side. You have seen how to draw that. So this is the pole of the mirror. So now here you have to be very accurate. Be very what? Accurate. Otherwise, it will affect the formation of the image. We said, let me assume that the distance from here, let me take it to be, I can draw mine to be at, let me take it to be 4. Okay? I think that, or we can take it to be 3. We can take it to be 3. So which means mine will be here. We'll have this. So this is my principal focus. Measure yours. You can put it to any distance, but they must be equal. But they must be equal. Then center of curvature will be here, 3. This is our center of curvature. So this distance here, they must be equal. They must be equal. That's why we say the focal length is equals to twice the radius of, focal length is a half the focal length. Radius of curvature is a half the focal length. What is twice the focal length? Sorry. So we have our F here. Then this is our point C. The object must be beyond C. Beyond is this side. Okay? I think that. So which means our object is going to be here. So we are going to place our object here. Put it to any height of your choice. I can put mine like that. This is my object, which is standing upright. The object must be real. It's standing like that. Okay? Yes?
Teacher,
Yes?
should the object and the center of curvature be the same distance?
No, the distance from here, from here up to this point must be equal to the distance from here up to this point. They must be equal. If from here up to here is 3 centimeters, even from here up to here must be 3 centimeters. Okay?
What of that of the object?
No, the object should just be beyond. We just put it any point behind this point. Okay?
Okay.
Yes.
Okay.
But what is important is this: the position of C and the position of what? F, the center of curvature and the principal focus. Okay? Are we ready? Have we put this one now?
Yes, teacher.
So now the first ray is from the object, from the top of the object like that. It will come like this. Members, this ray is what? Is parallel to the principal axis, not so? Is parallel to the principal what? Axis. What will happen to it after reflection? What will happen to it? It will be reflected through. It will be reflected through the principal what? Focus, not so? Like this. It will be reflected. Just follow the rule. Just follow the rule I've given you. So this one will be reflected like this, or like this. Then again, we said for image to be formed, we must need 2 or more rays. So now again, a ray of light will pass through the principal focus from the object from the same point. Will pass through the what? Like that. Will pass through the principal focus like this. We said when a ray of light is passing through the principal focus, what will happen to it? It will be reflected what? Parallel. It will be reflected what? Parallel. It will be reflected parallel. It will be reflected parallel. So can we draw that? Shall I have this one here? Yes, there we go. So where the 2 rays are meeting, where the 2 reflected rays are meeting, where the 2 reflected rays are meeting, that will be where the object is going to be formed. So which means our image will be formed here. Our image will be formed here. Our image will be formed where? Here. And it's inverted. It's inverted. So this is our image I. That is our image I. Members, have you seen how the image is formed? Have you seen that?
Yes.
What can you say about this image? The nature, who can give me the nature of this image? Nature, let's look at the nature of the image. Nature of image form. Is it real or virtual? Remember, is it real or virtual?
It's real.
Real.
The image is what? Real. Why is it real? Why is it real? Because it's formed on the same side of the what? Of the mirror, right?
Yes.
What else? When you look at the size of the image and the size of the object, what can you say? Is it diminished or magnified?
Diminished.
Is diminished. Good. The image is what? Diminished. What else? What else?
The image is inverted.
The
Is
image
it-
inverted. Good. Inverted. Good. What else? What else? Yes. The image is formed between C and what?
F.
C and F. So form between what? Between C, center of curvature, and the principal focus. Those are the four properties. Those are the four properties which I've listed them down here. Position, the image is formed between F and C. Nature is real and inverted. Size is what? Is it? Diminished. Members, are we together on that?
Yes.
Let's look at the second one. We just keep on changing the position of the object. Now the first one is it? The object was at what? Was beyond C. Let's look at when the object is at the C. Now this time the object is going to be at the same point at the center of curvature. So let's look at that. B, object, O at center of what? At center of curvature. At center of curvature C. So we draw our principal axis. Then we draw the line here, the line which is presenting the reflecting surface of the mirror. Then you just put a small curve like that. This is the pole of the mirror. I said you have to be very accurate here. This time I'm using 4. So this is my F, then this is my what? My C. Okay. So members, where is the object? Where is the object going to be placed? The object is at what? At a C, at the center of curvature. So let's assume that is here. So this is where the object is. The object is there. O. The object is there. So we draw again. We follow the steps. A ray which is parallel. We draw a ray which is parallel to the principal axis, is reflected through the center of curvature. I mean, it's reflected through the principal focus, like that. Like this. Then a ray of light passing through the principal focus, sorry, passing through the focal point, 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 is reflected parallel, to that point. So this is incident, this is reflected. You can see where the image is formed. The image is formed at the same what? Members, the image is formed at the same what?
The same point.
At the same point. So let me use a red pen to make it look different there. Let me use a red pen. Like that. So this is our what? This is our image. So what can you say about the nature? What would be the nature of the image? Nature of image form. Who can give us one? Who can give us the nature of the image form?
The image is real.
The image is one is what? Real. 2.
Inverted.
Good. Inverted. The third one. Members, you look at the size of the image. Look at the size of the image and look at the size of the object. They are almost the same, not so?
Yes.
Huh? You can see from, let me give you from here. The same size as the what?
Object.
That's the object. You can even see from our diagram here. Same size as the what? As the object. Then the last one is formed at what? What is the position? The image is formed at? Formed at? At what? At center of?
Curvature.
Center of curvature. See. That's how you determine the nature of the image's form. Let's proceed. The third one, let's look at when the object is between C and what? And F. Now let me just, to make it simple, you know what C is standing for, you know what F is standing for. Okay?
Yes.
So the object, we started when it's beyond, we came at point C. Now let's look at when it's between. How is the image going to, what will be the nature of the image form? What will be the nature of the image form? Now, okay,
Yes, teacher.
you're not dozing, eh?
I'm not.
What about Alexandra? Alexandra, you are good at dozing. I remember very well.
I'm not dozing.
Yeah. What about Letitia? By the way, Gabriela,
Yes.
you have stopped dozing these days?
Yes.
Yeah. Please, can you measure the distance? Which distance should we use? I'm using 4. Let's use 4. I told you this distance must be equal. Must be what? Equal, because we have proved it theoretically. They must be equal. For me, I'm using 4. For you, can use any of your choice. You can use any as long as your book can accommodate. Okay?
Yes.
This is my F. This is my what?
Yes.
Okay.
Can I ask someone a question? The distance from point C to P is called what? Who can give us? What is the name of that? What is that? It's called what? The distance from C to P is called what? Members, it's called what? The distance from here up to here is called what? Radius of?
Radius of curvature.
Radius of curvature. Then the distance from here up to here is called what?
Focal length.
Focal length. Good. So our object is here, members. Our object is here. Our object is between, is what? Between, so I put it there like that. This is where my O is. So as usual, with a ray of light parallel to the principal axis. When you reach here, what will happen to it, members? It will be what? Reflected, no, sir?
Yes.
It will be what? It will be reflected through the principal focus like that. Members, are you following me?
Yes.
Then again, a ray of light through the principal focus from the object. Let me extend my mirror a bit. Let me extend my mirror. Like that. It must pass exactly at that point. Exactly at that point. When you reach here, what will happen to it? It will be reflected. It will be what? It will be reflected. It will be reflected parallel to the principal axis, like that, like that. Members, I did not plan well. You see how mine is going? It's formed up to this point here. Up to this point here. Mine is up to here. The image is up to this point. So this is the image. Members, is yours also like that?
Yes.
So what can you say about the image? What is the nature of the image? Who can give us the nature of the image? When you look at the size, of the image and the size of the object, what can you say about it? The image is bigger. So if it's bigger, which means is what?
Magnified.
Magnified. Good. The image is magnified. You can see from our working there. What else? Is real. The image is what?
Real.
Real. What else?
The image is inverted.
The image is inverted. Inverted.
The image is formed between.
Beyond is beyond, not so.
Beyond center of curvature.
Yes, it's beyond C. It's beyond what? Beyond C. As simple as that. Now we have seen when the object is between. Now let's see what if the object is now at point F. You see how we are moving? We started from beyond, we came to C, we came to between. Now we are at point what? F. So what will be the nature of the image? So the next one, this was what? D. So let's go to D. Object at F. Object at F. Object at F. Object at what? At F. So let's draw. Let's draw that. I'm still using 4. So the object is at F. The object is at F. The object is at F. This is where our object is. This is where our object is. So a ray of light, a ray of what? Light, parallel to that point. What will happen to it? It will be reflected, not so? Through the principle what? It will be reflected through the principal focus, like that. So now at this point here, because now there was supposed to be a ray passing through the what? The principal focus. But now the object is at this point, so which means a ray of light must come from the center of curvature. Must come from where?
The center of curvature.
Like this. We said when a ray of light from the center of curvature, what happens to it after reflection? It will be reflected along the same what? Along the same path. Not so?
Yes.
So draw that. So this one shall come like this, like that. You extend it there. You extend it. So behind there, it will be dotted. Behind there will be dotted. Even here, extend this one. Extend this one. Like this. Members, are they going to meet? Have you seen any rays meeting here?
No.
No.
So what does it mean?
They are parallel.
So which means the image, we can say the image is going to be formed at infinity. The image is going to be formed at what?
Infinity.
At infinity. So you can see it from there. So this one should be reflected and along the same path. So one, nature of the image. Nature of the image. One, the image is formed at what? Formed at what, members? At in what?
Infinity.
At infinity. Then the third one is remove this one. It's not real because we can't see it. Okay? It's not real. Are you together, members?
Yes.
So the image is what? We can just say is magnified because we can see how it's going to be formed. The image is what? Is what?
Magnified.
Magnified. Those are the only two. This one is wrong. It's not supposed to be real and inverted. That one is not correct, please. Okay? Okay?
Yes.
These two, they're off. These two, they're off. The image is just what? Magnified. The image is what? Magnified. Yes. Because we cannot see it. Are you seeing it from our diagram here? Are you seeing it is real?
No.
No, we can't. Are you seeing it inverted? Are you seeing it inverted here?
No.
No. But we can see that if you see the way these rays are going, it can show that the image is going to be what? Magnified. Okay?
Yes.
Yes, those are the only two things we are seeing. Then the next one is what? What if the object, now the object is between what? F and what? P. Between F and what? And the pole of the mirror is here. So can we see that? E? We have 2 minutes remaining. Let's hurry. Object between F and P. F and P. F and P. Let's draw it very fast. So I just put it like this. I measure 8 there, and here. Good. So this is C. This is F. So the object is between. This time the object is between. This time the object is between. Like that. The object is between. So what does this one mean? What does this one mean? So a ray of light parallel to that, like this. Are you seeing that, members?
Yes.
It will be what? It will be reflected. It will be reflected through the principal focus, like this. Then again, a ray of light through the center of curvature. Through the center of curvature, like this. Reflected along the same path. Members, we have less than a minute. We have less than a minute. So when I extend this line, when I extend this like this, and I also extend this one, and I also extend this one, you find that they are going to be formed at a certain point here, not so?
Yes.
So the image is behind, which means the image is what? Virtual, right? So I will use dotted. I will use dotted line. You can see it like that. So this is our image. So what can you say about the image? Members, let's join back and then I just summarize this, okay?
Okay.